CPU. The central processing unit, the one chip everyone's heard of, and the one almost nobody can actually explain without saying it's the brain. Here's the thing. A CPU is a generalist. It handles anything you throw at it. Opening a browser, running Excel, decoding a video, checking if your mouse moved. And it does it sequentially, one task at a time, but at insane speeds. Modern ones run at 3 to 5 gigahertz. That's billions of instructions per second. Intel kicked this whole party off in 1971 with the 4004, a chip with 2,300 transistors. Your current CPU has tens of billions packed into a fingernail of silicon. Today, you're looking at 4 to 24 cores in a consumer chip like Apple's M series, Intel's Core Ultra, AMD Ryzen. All these CPU has enough cores to make your life smooth. Each core is basically a mini processor that can run its own task. Think of a CPU as that one kid in school who was solid at math, history, English, and gym. Never the best at any single thing, but you want them on every group project. The catch, CPU are terrible at doing the same small task a million times in parallel. Ask one to render a 4K frame and it'll cry, which is exactly why we invented the next one, GPU. Graphics Processing Unit, originally built for video games, accidentally became the most important chip of the AI era. Where a CPU has 16 brilliant cores, a GPU has thousands of simple ones. It's the difference between hiring one Nobel laureate and hiring a warehouse full of interns. If the job is doing the same small math problem a million times, the interns win every time. And it turns out rendering pixels, training neural networks, and mining crypto all look like that exact same problem: massive, parallel matrix math. NVIDIA's RTX 5090 packs over 21,000 CUDA cores. AMD's Radeon lineup fights in the same weight class. These things chew through ray-traced games, train GPT-class models, and melt your power bill. An RTX 5090 pulls 575 watts under load. That's a microwave. But here's the dirty secret of the AI boom: ChatGPT, Midjourney, Stable Diffusion. None of them run on CPU. They run on racks of GPU. NVIDIA's market cap crossed $3 trillion because the world quietly needed 1 million of their chips all at once. TPU, Tensor Processing Unit. Google's answer to, what if we built a chip that only knows how to do AI math and absolutely nothing else? Released in 2016, the TPU was Google's admission that even GPU were overkill for what AI actually needed. Neural networks are basically endless matrix multiplications. So Google built silicon that only does that at ludicrous speed. No graphics, no physics, no video decode. Just tensors. Think of a TPU as a NASCAR car. It can only turn left, but on an oval track, it humiliates any Ferrari. Google's latest TPU v5p powers Gemini, the AI in your search results, and almost every neural network inside Google's empire. You can't buy one. You rent time on it through Google Cloud. The trade-off is flexibility. A TPU is useless for anything outside machine learning. But for the thing it was built for, it's faster per dollar and per watt than almost anything on Earth. NPU. Neural Processing Unit. The quiet chip sitting inside your phone and your new laptop, doing AI without nuking your battery or phoning home to a data center. Apple slid the first serious one into the iPhone X in 2017, the Neural Engine. Qualcomm followed with Hexagon. Now every Copilot Plus PC is required to have an NPU capable of 40 plus TOPS, or trillions of operations per second, just to earn the label. What does it actually do? It's the reason your phone blurs backgrounds in real time, transcribes your voice offline, and unlocks with your face in 200 milliseconds. It's also why your new laptop can run a local language model without the fan sounding like a truck engine. An NPU is basically a TPU's pocket-sized cousin. Smaller, dumber, but sips power like it's rationed. When your iPhone edits a photo instantly, that's the NPU, not the CPU, doing the quiet heavy lifting. LPU, Language Processing Unit, a chip so new and so specific that most people in tech still haven't heard of it. Grok, not Elon's Grok, this is the chip company with a Q, built the LPU specifically to run large language models at speeds nobody thought were possible. We're talking 500 plus tokens per second on Llama 3, where a standard GPU setup might do 50. It doesn't train models, it just runs them. Faster than anything else alive right now. The whole architecture is built around the fact that language models are sequential, word by word, token by token. And GPU, for all their brute force, weren't built for that rhythm. If you've ever used Grok's demo and watched the response fill the screen instantly, like it's cheating, yeah, that's the LPU. IPU. Intelligence Processing Unit, built by Graphcore, a British chip company that tried to outthink NVIDIA, and mostly ended up as a cautionary tale. The idea was genuinely brilliant. Instead of GPU that do parallel math in straight lines, build a chip that thinks in graphs. A spiderweb of 1,472 independent processors, all talking to each other at once. Great for certain AI workloads. Problem is, the world standardized on NVIDIA's CUDA software before Graphcore could get traction. The IPU is technically impressive and commercially struggling. A reminder that the best chip doesn't always win. The chip with the best software ecosystem does. DPU. Data Processing Unit, the bouncer of the modern data center. NVIDIA's Bluefield, AWS Nitro, Intel's IPU. They all do the same boring, essential job. Handle the infrastructure grunt work so the CPU and GPU don't have to. Networking, encryption, storage traffic, security checks. In a modern cloud server, the DPU is quietly shuffling terabytes per second between machines, while the GPU focuses on the actual AI model. You'll never interact with one directly, but if you've ever used AWS, Azure, or Google Cloud, a DPU handled your packet. QPU, Quantum Processing Unit. And this one's going to break your brain a little. A regular chip uses bits, 0 or 1. A QPU uses qubits, which can be 0 or both at the same time, thanks to a property called superposition. Instead of checking every possibility one by one like a CPU, a QPU explores all of them simultaneously and collapses into the right answer at the end. It's less a faster calculator, more like asking the universe to do your homework. IBM's Condor chip crossed 1,121 qubits. Google's Willow chip, released late 2024, solved a problem in under 5 minutes that would take the fastest supercomputer on Earth 10 septillion years. That's a number older than the universe, many times over. The catch? QPU needs to be cooled to near absolute zero. Minus 273 degrees Celsius, colder than outer space. They're the size of a chandelier. They're wildly unstable. And they're genuinely useless for running Chrome. But for cryptography, drug discovery, and simulating molecules, they're about to rewrite what's possible in the next decade. So here's the takeaway. For your everyday computer, the CPU. For gaming and training AI, the GPU. For cloud AI at scale, the TPU. For AI on your phone and laptop, the NPU. For blazing fast language model responses, the LPU. For data center plumbing, the DPU. And for problems we currently can't solve at all, the QPU is the answer. Hey, I made a video on some of the most important data structures. Definitely check it out, it might really help you. And with that, I'll see you in the next one.